The inverse of a matrix. In this video, we consider how to find the inverse of a 2 by 2 and 3 by 3 matrices. Before you work through this video, you will need to know how to find the determinant of 3 by 3 and 2 by 2 matrices. If necessary, you should refer to these videos which cover these topics. Thanks for watching this video, and don't forget to like, subscribe to the channel and activate the notifications. It's very important to the continuity of this channel. In the algebra of scalars, numbers, if we multiply any number by 1, we get the same number. 7 times 1 is 7. Any number times 1 is the number itself. The number 1 is the multiplicative identity for real numbers because any number times 1 is the number itself. We also know that if we divide a number by itself, the result is 1. 7 divided by 7 is 1. Dividing a number by itself is exactly equivalent to multiplication by the reciprocal or inverse of the number. Unless the number is 0, there is always a unique reciprocal of the number. Let's see how it works in the algebra of matrices. We know when we multiply a matrix by unit matrix, the result is the matrix itself. The unity or identity matrix is the multiplicative identity for matrices. But we do not divide by a matrix. For matrices, there is no such thing as division. So, if we want to multiply a matrix by something that results in the multiplicative identity, which in this case is the identity matrix, we must multiply the matrix by its inverse matrix. The inverse of a 2 by 2 matrix. The inverse of the matrix A is given by. To get the inverse of the matrix A, we swap the positions of A and D, put negatives in front of B and C, and divide everything by the determinant of A. At this point, you should note that if the determinant of A is 0, the matrix A has no inverse because it is never possible to divide by 0. It is for this reason that some matrices do not have an inverse. We can tell whether a matrix has an inverse by evaluating its determinant. If the determinant of A is 0, then A does not have an inverse. If the determinant of A is different of 0, then A has an inverse. Find the inverse of the following matrices. To begin, we write the formula to find the inverse of a 2 by 2 matrix. To find the inverse, we just need to substitute the value of the determinant of A into the formula, swap the positions of A and D, put negatives in front of B and C, and finally, perform scalar multiplication. To find the inverse of matrix B, we do the same. The inverse of a 3 by 3 matrix. The inverse of a 3 by 3 matrix is difficult to compute by hand, and usually a calculator that computes inverse matrices is useful in this case. But in my opinion, it's worth knowing how to calculate the determinant of a 3 by 3 matrix by hand. To explain how to calculate the inverse of a 3 by 3 matrix, you should know what an adjoint of a matrix is. The adjoint of a matrix A is the transpose of the cofactor matrix of A. It is denoted by find the adjoint of the matrix A. To find the adjoint of a matrix, first find the cofactor matrix of the given matrix. Pay attention. Now we find the transpose of the cofactor matrix to get the adjoint of the matrix A. Given a matrix A 3 by 3, its inverse is given by the adjoint of the matrix divided by the determinant of the matrix. Let's see how it works. Find the inverse of matrix A. The first step is to create a matrix of cofactors. This step has the most calculations. Now transpose all elements of the previous matrix to get the adjoint of the matrix A. Now we find the determinant of the matrix A. We pick the second column because an element is 0 and it simplifies the calculations. To find the determinant isn't too hard because we already calculated the cofactors. To get the inverse of matrix A, take the formula and perform the scalar multiplication.